In this video, I'm walking through a simple exercise in instantiating a module. Okay, so the idea here is we're using Verilog to connect different modules together. I've told you that modules are the building blocks for Verilog. So in this example, I have a module called Logic1 with a name identifier U1. I have a module called Logic2 with a name identifier V1. I have a couple of wires that help me connect things together. I have this exclusive OR gate. All these connect together to give me a circuit. Okay, so I can look at the repo that I have started here. Let me commit this as a starting point. Okay, and so if you look at the code, I have a test bench set up. I have RTL files. It has the Logic1 module. You can take a peek inside. It's just a simple logic function. It's not so much important what it is other than it defines what the ports are, inputs and outputs. So I have this all set up, but it's represented well with this RTL diagram. So what I want to do is actually push this all together or connect this all together using Verilog syntax. Okay, so the first thing is we have this timescale thing that helps set up the simulations whenever we run simulations. And so let's not worry about that. Let's just say this is a given thing that needs to show up in Verilog files. Okay, so I start and I want to define the module for demo. All right, so I told you in class that you give it the module keyword, you give it the name, you start with an open parentheses, I hit a couple returns, hit a close parentheses, and a semicolon. All right. From there, I've got this set up, and I want to end it with an end module keyword. All right, so module place for ports, and so the first thing I'm going to do here is I'm going to put all the inputs that I see. Now, initially, when we do our work, I'm going to try to color code the inputs and the outputs just to make it a little more obvious what we're looking at. So I see inputs A, B, C, D, and I. So I can say input A, comma, and you could technically say it's a wire. Let's go ahead and put that in so that we know what the default type is. If you don't put that, it defaults to wire. So we'll say input B is a wire. Get some spacing going on here. I get these to line up. Input wire B. Input wire C. Input wire D. So we have all the inputs. Then we need the output wire. And at this point, we have the ports are defined. Okay, so we can add a comment here. Define the ports. All right, so the next thing I want to do is define the wires. All right, in the diagram, it looks like a lowercase pw and lowercase tw, but I ended up implementing it with uppercase. So let's just go with uppercase and interpret these as uppercase variable names. Okay, so I'm going to have a wire for PW and TW. It turns out since these are scalars in the same size, you can list them on the same line. I could have done this also with the inputs. All right, I have all of them are scalars, all of them the same size. I could just make a list, right? But there's lots of different ways to do this. I'm just walking through a format that you can use to get started with. All right, so the next thing, so that's the first thing I did here is I defined connecting wires. Next, what I want to do is instantiate the different modules. And so just to make a point, let's do Logic2 first, all right? So I give Logic2, and then I give the name. The identifier for this particular module is V1, and then I put a parentheses and a close parentheses semicolon to help me get the brackets right, okay? I like to go down the page. You don't have to. You can go across. Sometimes for simple modules like this, I would have gone across, but I wanted to show you the formatting that is useful to help you keep things straight when the modules start to get a little more complicated. So we're using this syntax where we name the ports. So I can look under logic 2, I'm doing that one first. I know that I have input ports Q and R. All right. Now I noticed I didn't put any arrows indicating which direction everything's going, but I think it's fairly obvious in this circuit, mainly because of the exclusive OR gate. Things are moving from left to right. So these are the input side and this is the output side. So I have port Q is connected to PW, looking at the diagram, okay? And then I can say port R, input port R is connected to D, and then I have an output, so I put .t to give the port name. The dot is the format that says, hey, I'm about to tell you which port to connect to. So .t gets connected to TW, the wire TW. All right, and so this completes that instantiation for logic 2. All right, so I'll put a comment there. Logic 2 instantiation. All right, so next, let's go ahead and instantiate logic 1. So I'll put, again, the module name, the name identifier, which I told it to be U1. These are things you can make up on your own, but normally if I see an RTL diagram, I try to use what naming identifier that might show up in the diagram. Sometimes we don't bother to put those in the diagram, and you just add those separately as you input the code. Okay, so again, we start the port list. All right, open and close parentheses with a semicolon. All right, and then what I know is that I want input W is connected to A, and then input X is connected to B, and input Y is connected to C. And then we have output P is connected to PW. All right. I forgot the comma there. That's why it's nice to see things vertically, because things tend to line up and you can visually check, did I put the commas in the right places? So now I have logic 1 instantiated, logic 2 instantiated. I need to also worry about this exclusive OR gate that shows up over here on the RTL diagram. So the operator notation for exclusive OR is the cap, the shift 6. All right, so we're going to put an assign statement. All right, so we're assigning the output F to be the wire TW exclusive OR with input I. All right, so at that point, we finished instantiating the demo, and I've got this set up with the continuous improvement thing in GitHub. So if I commit these changes, it should run that workflow, and you'd be able to check to see if you have this working the way you expected. So we can look at the demo here and wait as it's running through the GitHub Actions. You could take a preview of that, and we'll hang on a second until we get the green check mark. Okay, and so now we see we have the check mark. I thought it was green, but it's blue in this case, okay, indicating that we have this connected and it passed the test. So there you go. There's a quick walkthrough of the process for instantiating modules. You don't need to know a lot about what happens inside the modules. You just make the connections in this fashion that we just described.